Okay, like I said, today we're going to talk about regression analysis. Last time we introduced the concept of the study of the relationship between two variables. We say those two variables change together, okay? It could be that when one is going up, the other one is going down. It could be that when one is going up, the other one is going up. For example, the more money you have, the more money you can spend on entertainment, the more money you can spend on travel, the more money you can spend on things that you need. But again, so there's a correlation there, okay? The other area we'll talk about correlation, or another example of correlation will be like the price of a good and how much of that good anybody buys. The higher the price, the lower the quantity people can buy. Not only because they think about, is it worth it, but also because they don't have as much money, or the money that they have will not buy them as much as they used to buy. So there is an income effect, and there's also some substitution effect. So today we're going to now ask ourselves a different kind of question in that kind of relationship. We are going to be able to estimate, I would say, the relationship. We're going to be able to ask ourselves, let us say that the older a car or a vehicle is, then the more money you can spend on the maintenance, okay? The question is, what is the nature of the relationship between maintenance of a vehicle and, say, the age of the vehicle, okay? Because we anticipate a positive correlation, okay? In the sense that the older a vehicle is, the more money you're gonna spend on the maintenance. But the question is, how much more money for each additional year? How much more money for each additional mile that you drive the vehicle? So I'm going to pull up a PowerPoint slide so that we can go through the way that we do this estimation. All right. So I'll share my screen. All right. Are you seeing the screen?
Yes.
Okay, you can see the screen. So I'll start from the beginning. Okay, so what we have here is linear regression analysis. Okay, and this linear regression analysis, the lecture is adapted from a book called Statistical Techniques in Business. Okay, so what is it we're looking at here? We're looking at the relationship between two variables, y and x. Okay, we call one a dependent variable. The dependent variable is a variable whose values depend on changes in another variable. Okay, a dependent variable is a variable whose values depend on changes in the value of another variable. And that other variable is called an independent variable. And we will call that independent variable x. Now, we're going to look at two things today, actually three things. We're going to look at the nature of the relationship, okay? Is it a negative relationship or is it a positive relationship? Or maybe there's no relationship at all, okay? Then we're gonna ask ourselves the size of the relationship, okay? The size. For example, like we said, when as a vehicle becomes older or as you drive it some more, the cost of maintenance will go up. All right. The question is by how much? Okay. Is there a minimum expenditure on maintenance? Of course, you know very well there's going to be a minimum. Even if you don't drive the vehicle, at least at the minimum, every 3 months or every 6 months, you change the oil. That's minimum. At the minimum, you're going to run the vehicle a little bit, and that's going to also lead to maintenance problems. You go into service the car, you maintain the air conditioning, you change oil, you might change brake fluid, you might change transmission fluid, just so that those things don't get rusty. Now, the other thing we're going to learn is how strong is the relationship? What percentage of changes in the dependent variable is explained by changes in the independent variable? It could be that the changes in the dependent variable are not really totally explained by changes in the independent variable, some of it. So we're going to ask how strong. Is it 10%? Is it 20%? Is it 30%? Is it 90%? It could be 95%. It could be 98%. So those things we're going to look at today. Now, we studied this kind of relationship using the equation of a line. We're going to use the equation of a line to study the nature of the relationship. Now, I will begin by looking at a perfect relationship. For example, the equation of a line is y is equal to a plus bx. Now, a is the constant value, okay, which is even if x is 0, y must have a value. For example, the amount of money you spend on food depends on your income. The amount of money you spend on entertainment depends on your income. Now, the question is, suppose you have no money at all. Are you going to starve to death? Are you going to not be entertained? You might end up borrowing money, but you're going to spend some money. Now, like I said, I'll give an example of, say, maintenance of a vehicle. How much is the cost of maintenance? Even if you don't drive the vehicle, you're going to change the oil at least once every year or once every 3 months. So there's going to be a minimum. But then the more you drive the vehicle, then the more you need to spend money. And that is true. And so B is the slope. So, and that slope is a rate of change, which is to say, for when x increases by 1, then y will increase by b, okay? So when x increases by 1, so I'm going to write it down here. When x changes by 1, then y changes by b, which is the slope, okay? And that represents a rate of change. Examples will be y is equal to 10 plus 5x. So when x is 0, y is 10, because 5 times 0 is 0. And so y will be 10 when x is 0. Then when x changes by 1, then y will change by 5. For example, and I'm going to do an example here, okay? If x equals, say, 3, that means that y is equal to 10 plus 5 times 3, which is equals to 25. All right? Okay, so that's an example. Now, another example will be like y is equal to 25 minus 2x. This is a negative relationship because the coefficient of x is minus 2. So that means that when x goes up, y will go down. When x goes down, then y will go up, all right? So for example, if x equals to 3, then y equal to 25 minus 2 times 3, which is equal to 19. Okay? Or you can say equals to 25 minus 6, which is equal to 19. All right. So now, what you see in what we have done, and the reason I said this is a perfect relationship, is that once you know the value of x, you can calculate the value of y exactly. It's always exact, okay? So if this is all that we can do, then regression analysis in statistics has nothing to contribute. The reason that now we do regression analysis is that now we have imperfection, okay? We have imperfection. That is to say, we use the same equation, y is equal to a plus bx, but then we add e, which is an error, all right? And I'll give you a good example, all right? Now, let us say that you have me, you have Mahamudu, and you have Omar, all right? And the more money that you have, the more money you can spend on food. But maybe Omar does not like food as much as I do. Maybe Omar has other needs for money. And so that means that even though Omar is going to spend a little bit more money on food, but he's not going to spend exactly the same amount of additional money on food as I do because he has one extra dollar. Okay. So this is why regression analysis becomes very important. And this is why we introduced the concept of a scatter diagram. I think you all remember what we showed in the scatter diagram. We see that the relationship between y and x has a tendency, but it's not perfect. Okay. Let me see if I can pull up some data, and we can go through that again. Okay, I'm going to stop sharing on this, and we're going to use some example to illustrate the point we're trying to explain. Okay, for a minute. I will stop sharing this, and I'm going to share a different screen right now. All right, are you seeing a new screen? Hello?
Yes.
Yes, sir.
All right, so you're seeing a new screen. Now, this is a screen on maintenance and the age of a bus, okay? The new screen on the maintenance expense and age of a bus. So let us see what happens. You can even look at the screen on age of a bus and how many miles, okay? The older a vehicle is, or the older the bus is, the more mileage you put on it. So let's just take 2, maintenance expense and age. Okay, I'm gonna insert, and I'm gonna take charts here. I'm gonna take regress, the scatter diagram. See, I'm taking a scatter diagram, and you can see that Okay, there's a tendency here. The higher the age of the bus, let me see. Okay, I'm going to do it another way. See if we can see the point a little bit more clearly. Mileage and age, another example. The older the bus, the more mileage you put in it. That's another example. This is not giving us what we want. I mean, we've seen the example already, so I'm just trying to see if I can make it clearer. All right. So you can see this. You can see, again, there's a tendency here. Okay, the older the bus, the higher the cost of maintenance. All right, but that makes our point. So I'm going to stop share and bring up our PowerPoint. All right, so, but what you saw in the illustration there is that even though you see a tendency, the relationship is not perfect. Okay, and this is where regression analysis comes in. And so we try to use regression to estimate the relationship. Okay, so like the example that we gave with the equation, and I'm going to bring that equation back up. Okay, like here we have the equation 10 plus 5x. All right, so now once you know x, you can calculate y exactly. Now in regression analysis, we don't know what the A value is. We don't know what the A value is. We don't know what the B value is. We use the imperfect data from statistical observation to try to estimate. And mark that word. What we are trying to do is to estimate. So how do we estimate the relationship? Okay, we use regression analysis. So our objective is to estimate A and to estimate B. And I'm going to write that down, okay? I'm going to write that down. Okay, what's the objective of regression analysis? Okay. So we have y is equal to A plus bx, okay? Okay, plus e, because we recognize the error. Our objective is to estimate A using what? we're going to use A hat. That is, A hat is the statistical name for the estimate of A. So I'm going to insert A hat. We're going to use A hat to estimate A. And we estimate B using B hat. Okay. We're going to give B hat so due respect. We're going to estimate B using B hat. Okay. So now remember that these are estimates. Okay. A hat and B hat are estimates. Like this is trying to give me a hard time. So I'm just going to do what I have to do. All right. So, well, I mean, that's imperfect, but so now, so how do we go about doing this? How do we go about doing this? Your PowerPoint, original PowerPoint slide provides an example. As you can see here, you're looking at an example of copiers sold and sales calls. So now, suppose you are a salesperson. Suppose you're a salesperson. How do you, what will make you sell copiers? The more calls you make, the more copiers you sell. All right? The more calls you make, the more copiers you sell. As you can see here, the scatter diagram shows it very clearly. Shows it very clearly. Are you seeing the scatter diagram? You see the scatter diagram shows that the more calls you make, the more copiers you sell. All right. So now the question becomes, how do you estimate this? Now, as you can see, why is it that you don't have a perfect line joining the number of calls and the number of copiers sold? Now, a number of reasons. Luck, good luck or bad luck, okay, of the salesperson. Now, the salesperson's skill in convincing somebody to sell, or just the luck that you call somebody who simply does not need a copier or does not have the money to buy a copier. So these are the reasons why you don't see this perfect line connecting the number of calls and the number of sales or the amount of sales. And so you can see that the relationship is not perfect. All right, so that's an example. So how do we go about it? And what is our objective? As you can see here, your objective is to draw a line exactly in the middle of that scatter diagram. Okay, you draw a line exactly in the middle of that scatter diagram. You see the original scatter diagram on the left here, and you want to draw a line perfectly in the middle. And that line is called the line of best fit. It's called the line of best fit. The principle, the mathematical method that we use is called the least squares principle, or the least squares method. And the full name is ordinary least squares. Okay? It's ordinary least squares principle. And OLS. It's called the OLS principle, or ordinary least squares. So now, how do we implement ordinary least squares, and what do you get? Let's see what we get. All right. Now, that's a mathematical method that you use. I'm going to switch this. All right. Now, I'm going to show you this, and then we're going to walk through an example. All right. We're going to walk through an example. The mathematical method we use for ordinary least squares, this is the ordinary least squares formula. Okay, the ordinary least squares formula. All right. Now you estimate B hat, you get the data for X, you get the data for Y. So you can see here, the number of sales is Y. If you make more calls, you make more sales. So sales depend on calls. Okay, are you getting me? Hello, are you with me?
Yes.
Okay. Sales is the dependent variable. The amount of sales that you make depends on the amount of calls that you make. All right. And so you see the data on sales and calls. Now, once you have this, you then estimate A hat and B hat. I have done this estimate here. Okay. I have done the estimate here, and I'm going to show it. Okay. Now I call it A hat and B hat. Okay. I could easily come here and see if I can put that there. This is called this A hat. All right. This is A hat. This is B hat.
Professor,
Yes.
will you let us know the formula on how to get A hat and B hat?
Yeah, I'm going to show it to you. Of course I will. I'm going to do an example also. We're going to walk through an example. Okay. This is B hat. All right. This is B hat. That is A hat. And we're going to also calculate how strong is the relationship. All right. Now, that is the formula. All right. That is the formula. First of all, you calculate Y bar, you calculate X bar. All right. So how do you implement this formula? How do you implement the formula? All right. Omar, that was your question. Am I correct?
Yes.
Okay. Your question was, how do you implement, what's the formula for calculating A hat and B hat? All right. So you use this formula here. As you can see, I highlight the formula for B hat. You calculate B hat first. All right. And from this table, you can see I calculate Y bar, I calculate X bar, and then you calculate Y minus Y bar squared. You calculate X minus X bar squared. And then you calculate Y minus Y bar times X minus X bar, which is what you see in this formula. You see them in this formula? X minus X bar times Y minus Y bar. You get the summation of that, and you divide by the summation of X minus X bar squared. Okay. And so you plug in those numbers from here, and I'm going to show you how to get them. Okay. And you sum. Okay. So you sum Y minus Y bar squared, you sum X minus X bar squared, and you sum Y minus Y bar times X minus X bar. Now you see Y minus Y bar here. Okay. So you calculate Y bar, which is the average of Y. Okay. The bars are the averages. You calculate the average of Y, the average value of Y. This is Y over here. You calculate the average, and then you subtract each Y from this average. So this is what you see here. 41 minus 45 is minus 4. 51 minus 45 is 6. 29 minus 45 is minus 16. You do that for every value, and then you come here and you get the square. That is, you multiply each of these values by itself, and you get the sum. Okay? You do the same for X, and then you multiply Y minus Y bar times X minus X bar. 4 times 0 is 0. But minus 4 times minus 56 is 224. And 6 times 8 is 48. And 15 times 32 is 480. So when you're done, you sum them also. And so this is what I have done here. Okay. The sum of X minus X bar times Y minus Y bar is 6672. And the sum of X minus X bar squared is 25,600. And so you have B hat here, which is 6672 over 25,600. So you get 0.2606. All right. And then you get A hat, which is equals to Y bar minus B hat times X bar, which is 45 minus 0.2606 times 96, which gives you 19.98. This is how I got these numbers here. Okay, we're going to walk through an example. See how I got these numbers here? 0.2606, if you really want to expand that, and 19.98. So let's do an example. And we're going to walk through that example completely. All right. This is an application. Okay. This is an application. I'm going to pull up the MS Excel file. But before I pull up the Excel file, I need for us to understand the problem we are trying to solve. We are trying to solve a practical business problem. Okay? This is a practical business problem. And there are many applications. We've already looked at the application for sales call and sales, which is a salesman's problem, which is a sales manager's problem. Uh, uh, we looked at, say, maintenance of a vehicle and the age of a vehicle, which is an operational problem, a problem in operations management. Okay, so now we're going to look at a finance problem. Okay. If you study finance, I believe that when you took a class in finance, you heard about dividends. Am I correct? Hello?
Yes.
You heard about dividends, okay? You also heard about the price of a share of stock. You heard about that?
Yes.
Yes, sir. Yes.
Okay. So now in financial theory, and you will encounter it in Finance 250. So you don't have to go very far. You heard about dividends and the price of a stock. In financial theory, there are two main theories, okay? One theory is called the dividend irrelevance theory, which is what you have here, the dividend irrelevance theory. And the idea is that shareholders in a corporate stock do not care whether a company pays dividends. They don't care, because if they want cash, they will simply sell their stock. If the value of the cash if the value of the stock goes up, you sell it, and you take the difference between how much you bought it and how much you sold it, and that's your profit. Okay. And so the idea is whether or not a company pays dividend does not affect the price of their stock. Now, another theory is called bird in the hand theory. Okay, it's called bird in the hand, in the sense that this theory says that shareholders want a company to declare dividend. They don't want to have to wait for the stock to appreciate in value for them to go and sell it. They want their bird in their hand. Okay, and that theory says that dividends are relevant. The higher the dividends, the stock prices will go up. Okay, so now we want to test that theory. Okay, we ask ourselves, the price of the stock depends on dividends. So this is the dependent variable is price. Dividend is the independent variable. So we want to see what is the nature of the relationship, what is the size of the relationship. Okay. So today we're just going to go with estimation. Okay, we're not going to do hypothesis testing yet. We're going to do hypothesis testing next week, which is to say whether your estimates actually mean anything. Okay, this is the original data. Okay, this is the original data. The price of the stock is here Y, and the dividends per share is X. Okay, so we're going to pull up the Excel file and solve through a problem. All right, we're going to use the formula. Okay, we're going to use the formula. We're going to use this formula to solve through that problem. So we're going to take this out. We're going to replicate that. We're going to replicate that. All right. And I'm going to take away this Y bar because it's a different Y bar now. And we're going to take away this X bar because it's going to be a different one. And then we're also going to take different formulas. We're going to take the formula for B hat. All right. Okay, already the formula for B hat is here. And we're going to all right, so we're going to break this all out. Summation. We're going to find out about all of these. Just excuse me. All right, so equals. All right, so, and this will be equals. Okay, so now how do we get all these numbers? So let us start. How do we get all these numbers? So I'm going to stop sharing this screen and I'll pull up. All right. I'm going to solve. Are you seeing the new screen?
Yes.
Okay. So now I'm going to solve this problem from scratch. Okay. So that you can see how to go about it. All right. Now, the first thing that you do is you calculate the average of y. Okay. Going to you calculate the average of each variable, the dependent variable. You calculate the average of y. So let us calculate the average of y. This is the price. So we'll calculate the average. So we'll use the Excel function average, and we'll calculate the average of y. So the average of y is 52.3. So write it down, okay? Y bar is 52.3, okay? I'm going to write it down. Y bar is 52.3. So you write that down. And then X bar is 10.68. So you write it down. Okay. So what do you do next? X bar and Y bar are in location 32. So Y is in B. And so Y bar is B32. And X bar is C32. You guys following me? Hello?
Yes.
You're following me?
Yes, Professor.
Okay. So the average of Y is in location B32. The average of X is in location C32. And so Y minus Y bar, which is the location B, is equals B minus
X bar, Y bar,
$32.
average.
Okay, which is the average. You're subtracting from the average.
Mm-hmm.
Equals B2 minus $32. And so you do it for every observation right at the end, and you see what you have B $32 equals B2 minus B $32. Okay. See if we okay. So I say 0 there. We do the same thing for X bar. Okay. And we get the sum of that. Gives you a 0. So when you get a 0 here by subtracting X, if you add up X minus X bar or Y minus Y bar, you get a 0 here. So now let's go to the next stage. So the next stage is to get the square. You multiply each of these values by itself. You get Y minus Y bar to the power 2. So equals B 2 to the power 2. All right.
You have to square it.
You have to square it. And you also square the X minus X bar. You drag it down. All right. And you get the sum of those values. They are no longer 0. All right. All right. I'm saving my file as I go. Okay. So the next thing then is to multiply Y minus Y bar times X minus X bar. Okay. So you multiply D and E. You get it?
Yes.
You multiply column D by column E, which is Y minus Y bar times X minus X bar. So that becomes equals D2 star E2. Multiply that. All right. And you get the sum of that. Okay. Okay. So now you have to write down the summation. Okay. You have to write down the summation that you have, X minus X bar times Y minus Y bar. What is the sum of X times X bar times Y minus Y bar? Can somebody tell me?
Can you repeat that?
What is the sum of Y minus Y bar times X minus X bar? What is the summation of it?
Y minus Y bar
Times X minus X bar.
is 0.
No. The sum of Y minus Y bar is 0.
Yeah.
How about when you multiply Y minus Y bar times X minus X bar? What do you get?
But right here is 0 too.
It's not 0. This is it. See, this is why I'm saying you're not paying attention.
Oh yeah. Okay.
Okay. This is it here.
Something is kind of a little bit. So because the summation of the X minus the Y minus Y bar, when you look at the summation is 0, right?
Yeah, it is 0. It has to be 0. If it's not 0, you're doing something wrong.
On the X minus is 0, but what do you do? Okay.
But when you multiply the 2,
you get something.
You get something.
Okay.
The summation is something. But individually, y minus y bar, the sum of y minus y bar is 0. It has to be 0. The sum of x minus x bar has to be 0. Okay? But when you take x bar minus, when you take x minus x bar and multiply it by y minus y bar, and you go through all of it, the sum cannot be 0. You get the point now?
Yes.
Okay. So just give me a minute. Just give me a minute. Okay. Okay. So that is 2102.39. Okay. How about the sum of y minus y bar squared? What is it?
I'm writing down. I'm sorry.
Okay.
7,711.47.
Okay. The sum of y minus y bar squared is 7711.47. How about the sum of x minus x bar squared? What is it?
872.10.
872.10. Okay, so you write it all down. Okay, the reason I'm writing it down is that I'm going to go back to the PowerPoint and we'll fill it in so that we can now solve that problem. Okay, so we go back to our PowerPoint. Okay, so we see y bar is 52.3, 52.3, and x bar is 10.68. The sum of x minus x bar times y minus y bar, 2102.39. And the sum of x minus x bar squared is 872.10. And then we're going to get the sum of y minus y bar squared. I'm going to change this. It's equal to 7711.47. All right. So now we have all the numbers that we need. We have all the numbers that we need. And so B hat is equal to B hat is equal to 2102.39 over 872.10. And so what does it give you? Can somebody give me that number? Hello?
Are you talking to us?
Yeah, I'm talking to you. What's the answer there?
Oh, you want me to do the math?
Yes.
I just follow you. I'm sorry. I'll do it in my
It's
calculator.
2.4.
2.4. 2.4 is the answer. Okay, 2.41. Okay, 2.41. All right. What is A hat? Okay. What is A hat? Y bar is 52.
26.56.
That's correct. 52.3 minus 2.41 times 10.68. And what did you say? 26 point what? Hello? $26.55, am I correct?
Oh, I'm sorry. I was talking in the number macro. I have 25 point. Okay, let me do that again. I have 10.68. I have 25.73.
No. Omar, what did you say it was? Omar.
26.56.
That's correct. That's correct. Okay.
Wow.
That's correct. Okay. So now that you have these beautiful numbers.
Are you sure?
Yes, it is.
I've been doing it 3-4 times, but didn't the same number. 2.41.
All right. So now, what do you do with this information? What do you do with this information?
68. Obviously, the number is wrong though.
That is correct. 26.56 is the answer.
I did it 4 or 5 times. I get 25.73.
No, you're not doing it correct. Okay. If this is
Professor,
2.41 and that is 10.68.
2.41 times 10.68. I get 25.7. I don't know how you did that.
Well, 2.41 times 10.68 is 25 points change. But if you subtract that from 52.3, you're going to get 26.55.
Okay, down. Okay. Minus 15. Okay.
Yes.
Professor.
Yes.
What's the next step after this, after you find all the numbers?
Very good. This is where I'm going next.
26. Okay.
This is where I'm going next. So now you use this to write what you call equation of the model. All right. Okay. So here, y is equal to 26.55 plus 2.41 times x plus e. All right. So you are saying, what are you saying? What you are saying is that if a company pays zero dividend, then the basic price of the stock will be $26.55, which is your A, right? Remember, the equation of the model is y is equal to a plus bx. Am I correct?
Yes.
Okay. So A is 26.5. So you're saying that the equation of the model is that if this is zero, if x is zero, if the company pays no dividend per share, then the basic price of the stock will be $26.55. Now, if the company pays $1 per share, for each $1 per share of dividend, the price of the stock will go up by $2.41. You get the point now?
Mhm,
Yes.
yes.
You get it? So
Yeah.
it makes a lot of sense, right? It makes a lot of sense. So that is the equation of the model. And then you have other examples. We are running out of time. We didn't calculate the coefficient of determination, but I think we should do it in the amount of time left. I have some other examples here that I'm going to solve, and I will send you the solution, okay? And we're going to explain it next time, and then we go to hypothesis testing. We might spend a little bit more time next week. We go to hypothesis testing because it's very important that we do a hypothesis test, all right? Okay, so the next thing we're going to calculate is the nature of the relationship. What is the coefficient of determination? Okay, that is what we're going to do next. I mean, how strong is the relationship? Okay, how strong? How strong? Okay. Is the relationship? Okay, and that is what we call the coefficient of determination. And I think we talked about it last time, r squared, all right, which is r squared. R squared. All right, so the coefficient of determination is r squared. So what is r squared? R squared okay. The formula for r squared is equal to, I'm going to get that. Is E hat times all right. The formula for r squared is B hat times the summation x minus x bar times y minus y bar divided by the summation y minus y bar squared. So we have all our numbers, okay? And from here, we have the summation y minus y bar squared put it down here. And the summation x minus x bar times y minus y bar, we have it there. All right. And so this is equal to 7711.47 divided by, I'm sorry, 2102.39 over 7711.47. And who can help me with that arithmetic?
202.39 divided by 7711.47. 0.272.
0.272?
I got 0.27.
Yeah, 0.2726.
Okay. .276?
Yeah. Put 0.2726. Yeah.
0.2726. Okay. And which simply says what? It simply says that 27.26% of changes in stock price are explained by changes in dividends. Okay. Changes in stock price is explained by changes in dividends per share. That is the meaning of all of that calculation. So you have to bear that in mind. Okay. I have to remember that. That is a critical, it's an essential part of anything called regression analysis. Okay, it's a very, very important part of anything you call regression analysis. You must remember it. All right, so that does it for the day. But if you have any questions, please feel free to ask them.
Professor, I have a question,
Yes.
but it's about the last homework that we just did.
Okay.
I wanted to know if we had to do hypothesis testing for the homework, because I remember at the end of the stuff that we did on the last time, we used hypothesis testing. I wanted to know if we had to do that for the homework.
Well, the question did ask for hypothesis testing. Yes.
I didn't see that, but okay, that's why I didn't do it.
I will pull it up. I will pull it
Okay.
up. Because you have to do hypothesis testing. I'll save this file. I'll stop share for a minute. Let me share screen again. Hello?
Yes.
Yes,
Okay,
sir.
no, there's no hypothesis testing. Sorry. I was thinking about, you're talking about the assignment on correlation.
Okay.
Okay, there's
Thank
no
you.
hypothesis testing, but I'm going to do an assignment that includes hypothesis testing for correlation because I need for you to know how to do a hypothesis test. That was an error, but there's no hypothesis testing required.
Okay.
All right. Let's go ahead. Somebody was going to ask a question.
Professor, the two things that we went over today, those are all we need for the homework?
For the homework, yes. This homework just requires you to do to calculate
Okay.
The A hat and B hat, and also to predict. Now, remember, I showed you how to predict. If you know the value of X, what is the value of Y? So you use the equation of a line. And that use that model equation, you use the model equation to calculate. So if the price of, let us pull up one of the solution now. Share the screen, okay. So now you have the model equation.
Oh, Professor, we have to write a sentence after we're done, like you did before, like you did at the ending?
Yes.
Yeah.
You want something similar to that? Okay.
Yes. So here's the model equation. So if a company pays, the equation of the model is that okay. So if a company pays $2 per share, okay. Okay. If X equals to $2 per share, that means then that price is equal to 26.55 plus 2.41 times 2, which equals to 2.41 times 2 plus 26.55, which is at 1.37.
Professor, what about E? What about the variable E?
The variable E is an error. It's an unknown error. You get the point? The variable E is an unknown error. This is why you don't have it there. You find E by going back to the original data, and you get E for each observation. You get an error, but that now leads to higher levels of understanding of regression analysis. And I am not talking about a higher level that is beyond your level, no, but it's just a little time consuming. Okay. For example, if you take every value okay, so if you come in here and then you can create another column and then calculate y for each value of x, calculate the y hat for each value of x, you can get the E. So there's an E for every observation. Okay, that's called a prediction error. And that's it's not beyond what you do here, but I don't spend time because it's time consuming, but you can use it to study other aspects of regression analysis. But the point is that the regression analysis we're doing now is a very simple model. So spending time working on the implications of E is not really too valuable for an introductory course in statistics. I mean, this is just my own professional point of view. All right, any other questions?
No.
Okay. Hearing none, we will end the lecture. And then if I solve the one on the maintenance, I will just incorporate it for you in the PowerPoint slides. And you can study it based on what we did today for this dividend model and for the sales call model. And you can take it from there. All right?
Okay.
All right, then.
Good night,
Have a nice Thanksgiving.
Happy Thanksgiving to you too.
All right. Good night.